Algebra. We are wrapping up our unit and our book, actually, our second book, with PO45, determining the probability of compound events. So we've got a lot of probability stuff going on here. A help sheet for this unit is going to be very helpful because we've got a lot of formulas. We've got probability, we've got counting principle, we've got theoretical probability, experimental probability, overlapping events, mutually exclusive events, and now we have these compound events as well. So let's think of that word compound, something that you are familiar with. What is a compound word? If you don't know the definition, you just give me an example of a compound word. Anthony?
Is it like has something to do with like elements?
A compound in science, yes, and let's talk about that. In science, what would compound elements refer to? Oh, don't take out your stuff. We're not going to have you search through. Just do you know off the top of your head?
Oh no.
No. So anyone know what compound elements are? Or compound words?
I forget.
Okay. So compound elements are elements that are put together. Okay. They're like individual singular elements that are combined. Right. A compound word takes two individual words and puts them together to make a new word, like backpack. Right. Back and pack are words in and of themselves. Put them together, you've got the compound word backpack. Okay. So compound events, very similar process here. Compound events are two or more, spell events right, don't forget the E there, two or more events that happen together. Okay? Or two or more events that are put together would be another way to think about that. Okay? So tied to something you may have already heard before, compound elements, compound words, they're two individual things that are put together. Compound probability is the same thing, or compound event is the same thing, same idea behind it. So, and we're really going to only have time to go over maybe a few examples today here, but go back to the marbles. There are 8 red marbles, 5 blue ones, and 7 white marbles in a bag. And instead of just asking what is the probability of choosing a white marble or choosing a blue marble or a red one individually, the question is, what is the probability of choosing a red marble, replacing it, then choosing a white marble? The word then, right, that's your cue that you're dealing with compound probability, because then indicates order, right? First this happens, then this happens, okay? So you've got two individual events here that are being put together. You've got choosing a red marble, then you have choosing a white marble, okay? So we're going to start this by just answering the question, what is the probability of choosing a red one? Simple probability. One event, single event, what is the probability of choosing a red marble? As a fraction. The probability of choosing a red marble. Adrian, how many red marbles are there?
8.
8. How many marbles are in the bag? 20. So the probability of choosing a red marble is 8 out of 20. Right? Probability is successful divided by possible. Now, just for simplistic sake, if we were to simplify this, what would we get? Simplify the fraction 8 20ths. 4/10, go a little bit further.
2/5.
2/5, right? Both, if you put it in your calculator, you get 0.4, 40%, okay? But the probability of choosing a red one is 8 out of 20 or 2 out of 5. Now, what is the probability of choosing a white one? 7 out of 20, right? There are 7 white marbles out of 20 possible. Okay? So, true to its name, to find the probability of both of these things happening, a compound event, we're going to take these two individual probabilities and put them together. We're taking the probability of a red marble and we're taking the probability of a white marble and we're multiplying them to combine them together. To say, first do this, then do that, put them together, and we use the operation of multiplication to do that. So 8 times 7 equals 56. 20 times 20 equals 400. So the probability of choosing a red one, putting it back, and then choosing a white one is 56 out of 400. What percentage is that? 14%, right? If you divide this in your calculator, you get 0.14, which equals 14%. Okay? If we had, since we simplified it earlier, if we had used 2/5 as our probability of picking a red marble, I'll just put it over here. 2/5, which is the red, times the 7/20 of the white. 2 times 7 is 14. 5 times 20 is 100. There's that beautiful denominator of 100, because when the denominator is 100, what's your percentage?
It's like the
The numerator, right? That's why we like that. So this would be 14% also. So if you simplify 8/20 first, you get 14%. If you don't, you still get 14%. Okay? So it doesn't matter really whether you simplify or not. But if you don't have a calculator accessible, then simplifying might make this multiplication a little bit more easy. But the point is, that's compound probability. Okay? Putting two individual probabilities together and then combining them with that multiplication. Questions so far? Peyton? You awake? Good. All right. Practice one on your own. The probability of choosing a blue marble, which I can underline this in blue, replacing it, and the probability of choosing a red marble. So what you're doing here is, again, you're taking those individual probabilities and then combining them with the operation of multiplying. So first, what's the probability of a blue? Then, what's the probability of a red? And you're multiplying those two fractions together. Give it a try. Who is confident in their blue marble probability? Gregory.
10%. Yeah, 5 over 20.
5 over 20. Yep, and let's not worry about simplifying now or converting that to a percentage now. Let's get these probabilities up here. So 5 over 20 for a blue one. What's the probability of choosing a red one? We already have it up on the board, but what you come up with? Someone other than Gregory, thank you for your, Peyton?
8 over 20.
8 over 20, right? And so since we see this word then here, right? These two things are happening together, one right after the other. We want to know, let's combine them. What's the probability of both of these things happening? And we do that with multiplying. It's a really spread out expression here, but you can put it together, okay? So 5 times 8, multiplying fractions go straight across, right? 5 times 8 is 40. 20 times 20 is 400. And what is 40 divided by 400 as a percentage, Anthony? 10%. You have a 10% chance of doing that. All right? Questions on compound events, compound probability? William?
What happens if you don't?
Sorry?
What happens if you don't replace it?
Good question. So further on down the page, we're going to come across a situation where you don't put that marble back. Let's do that one together. But before we do, one final chance at questions on this one here. Okay. Gregory, you have a question?
Yeah, next one. What if you, because if you grab a white one and replace it and grab a white one again?
Yeah.
So you just do Same thing, just with 7 over 20 both times.
Yes. Yep. Yeah, when you put the marble back, your denominator doesn't change. But let's look at this one. The probability of choosing a blue one, not replacing it, then choosing a red one. This is perfect because we just did blue and red with replacement, right? Let's look at blue and red now without replacement. Anything change with the probability of choosing a blue marble that first time you reach your hand inside the bag? No, right? There was, how many blue ones were there? 8? 5. There were still 5 blue ones in there, still 20 marbles in the bag, so our probability is still 5 over 20. But now, William's noticing that we do not replace the marble that we just picked. So how does that affect the probability of choosing a red one now? Are there still 8 red ones? Yeah, because we didn't pick a red one, we picked a blue one, right? So there's still 8 red ones, but how many marbles are in the bag, Zoe? Only 19 marbles left, because we didn't put that first marble back, right? So when you don't replace it, your numerator doesn't change because it's a different color. We still have 8 red ones, but there are only 19 marbles left in the bag. So, is that a significant change? Well, we're multiplying these because they're compound events, and that's what we do. Just talk about that. 5 times 8 still gives us 40 for a numerator, but what's our denominator now? When we multiply these fractions together. Gregory? 380. What's 40 divided by 380? And if you get a long, nasty decimal, round to the nearest percent, the nearest hundredth, yeah. 11%. So not a significant change, but a change, right? Just the act of you not putting that first marble back increases your chances of completing this task, which makes sense because there's one less marble to mess you up here now, right? There's one less unsuccessful outcome in the bag. So 8 out of 19 is better probability than 8 out of 20. Okay? So watch out for that phrasing there, replacing versus not replacing. It does make a difference. Okay? Other questions? Does it make pretty good sense? I feel like yeah. So the plan for tomorrow, I don't want to rush this one because it is a PO. The plan for tomorrow is we'll work with this more in class. You'll also get your practice test. It'll be due on Friday, and Friday is going to be kind of a half retake day and half prepare for the test. Your test is going to be on Monday. I don't love Monday tests, but it's kind of the way the schedule ended up working out. So practice test tomorrow. And then it'll be due Friday. We'll go over it Friday, review. You have the weekend to review even more, make a help sheet, things like that. And then the test will be on Monday. Okay. So continue to work on this if you want. Otherwise, we'll do it in class tomorrow. If you finish this for tomorrow, because you're like, I got this. This is cool. Then you'll have your practice test to work on. Either way, you'll have something to do during class tomorrow. Yes, we'll go over the second page tomorrow together. So it won't end up being homework. It'll be an in-class thing. But if you just want to get it done because you like this stuff, then who am I to deprive you of joy? Not me. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Nothing? Not even like I like your tie or something? William!
Like your tie.
I just want to press the button. Thank you, William. All right, folks, that's high math.